In this video, we're going to talk about the effect of pressure on gas solubility. Okay, so typically, as the pressure, let's call that P, goes up, the solubility of gases also goes up. Okay, and when we look at that pressure, we're really talking about partial pressure. Okay, partial pressure. So some of you might be wondering, what is partial pressure? So if you imagine a closed container out here, and there's a liquid in this container, some of that liquid is going to go into the vapor form. So let's draw those little molecules of the liquid in the vapor form. What's going to happen is, as these molecules increase and go into the vapor form, some of them are going to try to exert a pressure back onto the liquid. So if you measure the pressure on the surface of this liquid, that's the partial pressure of the vapor form of the solvent out here, and that's the pressure we're talking about. So as this pressure goes up, solubility increases as well. Now, another way to think about this is, if the pressure goes up, that means more of these molecules in the vapor form are pushing down. Okay, when they're pushing down, they're actually trying to get into the liquid. Therefore, greater the pressure, more of them getting into the liquid, hence solubility goes up. Now, there is a law called Henry's law, which kind of tries to quantitatively deal with this effect. And Henry's law has this form where it talks about the solubility is equal to, there's a constant Kh, okay, that's Henry's constant, times the partial pressure of the gas. So the solubility of any gas is equal to Henry's constant times the partial pressure of the gas. And this constant, Henry's constant, is dependent on the type of gas that we're talking about. So for example, carbon dioxide will have a specific constant only particular to carbon dioxide. Nitrogen will have its own Henry's constant. Oxygen will have its own Henry's constant. Okay, let's do a problem on using Henry's law. So the problem out here says, it's asking us to determine the solubility of nitrogen, so that's S. And the nitrogen is dissolved in water at 25 degrees Celsius. It's exposed to air at 1 atmosphere. And then the partial pressure of nitrogen is given to be 0.72 atmosphere. Kh for nitrogen is 6.1 times 10 to the negative 4 per molar per atmosphere. So Henry's law states, can be expressed as solubility is equal to Kh times the partial pressure. Kh is given to us, the partial pressure is given to us. So in order to determine the solubility, we just have to take these two quantities and multiply them together. So that's going to be 6.1 times 10 to the negative 4 per molar per atmosphere. And I'm going to write this a little differently so that we can see how the units cancel out. Molar over atmosphere times 0.72 atmosphere. As you can see, the atmosphere cancels out, and that gives us a value of 4.392 times 10 to the negative 4 atmosphere. Now, if we want to correct for significant figures, then we want to stop here. So that's really 4.4 times 10 to the negative 4. And I'm sorry, that's not atmosphere, that should be molar. That's the solubility, molar. Have that made sense?